Assalamualaikum, we are from group CS1433D. We'll present the group project about the topic that we choose, which is logical equivalent.
My name is Siti Nur Alia Shahira binti Aminuddin and my student ID is 2022460122.
Hi, my name is Putri Nurisha Umaira binti Nurizan. My student ID is 2022497082.
My name is Nurul Syafiqah binti Muhammad Zawawi. My student ID is 2022848878.
Hi, my name is Siti Nur Aina binti Jamaluddin. My student ID 2022817854.
Definition for logical equivalent. Two statements P and Q are said to be logically equivalent and we write as P equivalent to Q. When the statement P is true, respectively false, if and only if the statement Q is true, respectively false.
Next, two propositions A and B are said to be logically equivalent or simply equivalent denoted by A equivalent to B if their truth tables are identical. Let us consider the conditional or implication statement. For conditional statement, we use symbol of P implies to Q. And then, for inverse statement, we use not P implies to not Q. Next, for converse statement, we use the symbol of Q implies P. And the last one is contrapositive statement, where we use not Q implies to not P.
Inverse. Inverse is the negation from conditional in which both hypothesis and conclusion are negated. For example, if today is sunny day, then Ali will walk to school. So P is today is sunny day and Q is Ali will walk to school. So P implies Q. Then the inverse would be negate P implies negate Q. If today is not sunny day, then Ali will not walk to school. Converse. Converse is the changing the rule of hypothesis and conclusion from the conditional. For example, if today is sunny day, then Ali will walk to school. So P is today is sunny day and Q is Ali will walk to school. So P implies Q. Then the converse would be Q implies P. If Ali will walk to school, then today is sunny day.
Positive mean contradicting both hypothesis and conclusion of the given proposition. For example, if today is sunny day, then Ali will walk to school, where the P is today is sunny day and the Q is Ali will walk to school. So it should be P implies Q. So for the contrapositive, it should be not Q implies not P, which means if Ali did not walk to school, then today is not a sunny day. Whether P and Q or not P and not Q, and P by conditional Q are logically equivalent or not. So for the truth table, the true value for P is true, true, false, false, while for Q is true, false, true, false. For not P is false, false, true, true, and for not Q is false, true, false, true. For P and Q is true, false, 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 and for not P and not Q are false, 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 true. For P and Q or not P and not Q are true, false, false, true. And for P by conditional Q are true, false, false, true. Since the true value for not P and Q or not P and not Q and P by conditional Q are identical, so we can conclude that they are both logically equivalent.
Next, the question for number 2 is given that the statement J implies to not K. Write the inverse, converse, and contrapositive of the statement. The answer is for conditional statement is J implies to not K, and then for inverse statement is not J implies to K. Furthermore, for converse statement is not K implies to J. And the last one, which is contrapositive statement, is K implies to not J.
So for question B, construct the truth table for the statement in A and determine the logical equivalent statement for each of the statement. Okay, from the truth table, we got the truth table for J is true, true, false, false. True value for K, true, false, true, false. Not J, false, false, true, true. Not K, false, true, false, true. J implies not K, false, true, true, true. Not J implies K, true, 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 false. Not K implies J, true, 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 false. K implies not J is false, true, true, true. Therefore, we can conclude that J implies not K logically equivalent to K implies not J, and not J implies K is logically equivalent to not K implies J.
For question 3, consider the argument below. If Josh joined a singing competition, then he will practice in Korea or Japan. Express in words the inverse, converse, and contrapositive of the statement. X is Josh joined the singing competition. Y is he will practice in Korea. Z he will practice in Japan. For the symbol, we denote as X implies to Y or Z.
The symbol for conditional statement is X implies to Y or Z. If Josh joins the singing competition, then he will practice in Korea or Japan. Next, the symbol for inverse statement is not X implies to not Y and not Z. If Josh not joining the singing competition, then he will not practice in Korea and Japan. Next, the symbol for converse statement is Y or Z implies to X. If Josh practice in Korea or Japan, then he joins the singing competition. And the last one is the symbol for contrapositive statement is not Y and not Z implies to not X. If Josh not practice in Korea and Japan, then he does not join the singing competition.
The conclusion, in logical equivalence, we will be able to construct the truth table and determine the logical equivalent, and in addition, logical equivalence can also be used and applied in many different situations in our daily life.
Lastly, we can differentiate between the conditional, inverse, converse, and contrapositive.